In this lecture, we are going to see circular linked list. So before that, let me ask you a simple question. Suppose a normal linked list is given to us. Okay. Suppose something like this is given to us, and I'm asking whether it is correctly printing the length or not. Okay. So we have already seen how to print length using the while loop, but here I do have a for loop. Let's just quickly see if this for loop is working correctly or not. Okay. So obviously, like, we need to have one check here. If head is null, which means there is no node. If head equal null, then return 0 because linked list is empty. Then return 0 because it is returning int. But anyway, suppose that it is already there. Okay, let's just see if this for loop is correct or not. So what we are doing, we are basically creating one pointer to a linked list, one pointer to a node, which is a little box, which is curr or current, and it is having its own little box. That is okay. I'm checking whether current is null or not, and I'm incrementing the current, and based on that I'm incrementing the result. So after this for loop, anyway, like after this for loop, when I'm here, although it is not required, but what I'm doing, basically I'm checking whether current is null or not. So basically I will be, after this for loop, I will be coming out of the for loop whenever current is equal to null, right? Whenever this condition becomes false, then I will be coming out of the for loop, which means whenever current will start pointing here, and then current will start pointing here to the next of this, then I will come out of the loop. So that was the same thing I was doing in the while loop also, right? So I hope that is okay to you, that this is also printing the length. Now one more thing I want you to revise, that whenever I'm doing, suppose I'm doing free of head or current or something like this, okay, and head is currently pointing, let's suppose there is a pointer. Let me go to the next page. Let's suppose there is a pointer which is pointing to a node. Let's suppose this pointer is current and this is pointing to a node which is something like this, right? And maybe this value is 5. Then whenever I say free current, then what it is doing actually, what it is doing, is it freeing this or it is freeing this? So whenever I say free current, it actually freed up the memory pointed by the current. So basically it is freeing up this, right? Which means now this memory is reusable. We have already covered this in depth in C programming. I'm not going to cover this again, but just to revise you that we are freeing this. Whatever memory pointed by the current, we are not freeing the current, okay? Whatever memory pointed by the current, which means this will be some address. Let's suppose this is 2000. So this will be free current, means this will be 2000, right? So I'm freeing the memory at 2000, right? So I hope that is okay to everyone. Okay, now let's go to the circular linked list. What is a circular linked list is that there will be a linked list, normal linked list, and instead of last node pointing to null, last node will be pointing to the first node. This is how we are creating a circular linked list. So this is a variant of linked list called circular linked list, in which also the now node points to the first node, right? In which last node points to the first node. So this is the difference between circular linked list and the singly linked list. Singly linked list means this points to the null, but circular linked list means this points to the first node. So let me give you an example. Suppose that this is the linked list that you have, right? And instead of last node pointing to the null, last node is actually pointing to the first node. This is the case. Let me just write some values here. Maybe maybe this is 1, okay, and maybe this is 2, maybe this is 3, maybe this is 4, right? Now can you tell me which one is the first node and which one is the last node? See, this is just a circle, okay? This is just a circle. 1 is sitting here, 2 is sitting here, 3 is sitting here, and 4 is sitting here. Now there is as such no convention of first node or last node, like it depends on what head is pointing to, okay? If I say that head is pointing here, right, then I will say that 2 is first node, okay? If I say head is pointing here, then I will just look at this linked list as a 2 as a first node, which means I will say something like this: 2, 3, 4, 1, and then 1 is the last node, right? And head is pointing here. So it is like not any convention, but it depends on the what head is pointing. If head is pointing to 2, then 2 is a first node. If head is pointing to 3, then 3 is a first node, like that, okay? So, and when I say last node is basically whatever node that is pointed to head, okay? So I mean, if you view this linked list like this, then 1 is the last node. and head is pointing to the first node and 1 is the last node. So this is the general convention. Otherwise, like, there is no such convention because this is circle. Whatever head is pointing to, this is called the first node. Whatever is whatever node is pointing to the head, okay, the node that is pointed by the head, then it is the last node, which means 1 is the last node. And like, you can basically view this linked list in the single line, and put the first node in the first, and put the automatically the last node will be at the last. Okay, so 1 is the last node here, 2 is the first node here. But suppose head is pointing to this, then which one is the first node? If head is pointing to this, then 1 is the first node and 4 is the last node. This is how the convention works. Okay, since this is a circle, like, it depends how you are viewing. If you are viewing from here, which means if you're viewing to 1, then you can say 1 is the first node and 4 is the last node. Why? 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, and 4 is pointing to 1. If you're viewing at 2, then you can say 2 is the first node and 1 is the last node, and so on and so forth. Right? I hope you got it. Now let me try printing the length of circular linked list. See, just to revise you, this is how we have printed the length of singly linked list, which means a linked list which was in the normal fashion, something like this, right? If the linked list is something like this, then I can print its length using the for loop or while loop, whatever. So let me try the for loop. So what I'm saying, that there is a pointer that is current which is pointing to whatever head is pointing to, and then I'm keep on iterating, and I'm saying current is not equal to null, which means whenever I'm here, I'm sure that that current is actually pointing to null. Why? Because current not equal to null is the condition. So out of this for loop, I'm sure that current will be pointing to null, right? Then only this condition will be false. Right? If this is true, then I will go inside the for loop. I know it is bit tricky to understand, but just see whatever the condition is there, and opposite of that condition will always be after the for loop or while loop or any other loop. Okay, so I hope you got it. Now yes, this is working fine. So what I was doing, I was keep on checking whether current is null, current is null, current is null, current is null. The moment current is null, I am saying that I am done. Now let me try the similar thing with a circular linked list, which means this is my circular linked list, and currently head is pointing here or current is pointing here. I'm asking the current to point to whatever head is pointing to. I can also modify the head, because head is just a local variable to this function, right? This is not a variable that is required for me to preserve. So this is a local variable. I can modify this head, but that's completely fine. I mean, if you want, you can modify this head in this case also. Like in this case, I think we need head, because I'm using this head. But in this case, I think we are not using the head, so we can use head instead of current. Anyway, let me just use the current in both of the cases. Okay, so current is pointing here and head is also pointing here, right? So since this is circular linked list, there won't be a null. So what I'm saying, that here it will be just like the whether current is pointing current will be here, then current I'm checking whether current is coming back to the head or not. So current is not pointing to whatever head is pointing to, so that's not correct, that's not correct. So in this case it will be correct, right? So if current is pointing here, then if current is pointing here, then current next and head are same, right? Because current next is storing, let's suppose this is 1000, then current next is storing 1000 and head is also storing 1000. But when you move one more time, then you can say that current and head both are storing 1000. So instead of null, if I can just replace this null with head, then I think it should work, the whole story should work. Are you getting? See, earlier it was null, but now instead of null I can just say head. So should it work or should it not work? Just think about it. See, it is supposed to work, but there is just a small problem. It is supposed to work, but there is just a small problem. Can you spot the small problem? This is current. The problem is that here, I mean, it will work actually, but there is a small problem, like the logic is almost correct, but here it will not even enter in the for loop at once, which means that it will just say that okay, current is head and this current not equal to head. So I'm just assigning current to be head, and then immediately I'm saying current is not equal to head. So this condition is immediately false, right? And it will not enter in the for loop at least at once. You're getting? See, what's the problem with this code? This is the code, then it will not even enter. It will not even enter one time in loop, right? Why? Because it is as good as saying for I equal to 0 and I is not equal to 0, right? I'm just assigning I to be some value 0 or any value I to be some value, and I'm immediately checking whether I is not equal to 0. So obviously this condition is always false, right? Why it is always false? Because I'm just assigning and immediately I'm checking, then it will be false obviously. So that is why it will not work. So how can I make it work? Just think about it. How can I make it? I want it to work. So how can I make it work? Just think about it, and let me know. See how it will work. Just see. This is the linked list that is given to you, right? And you want to print the length of the circular linked list, and this is a circular linked list that is given to you. Now the problem is that currently head is pointing here. The problem is that you want the current and head to be the same value, right? That is okay, but that will be true only if you start current from here. If I'm starting current from here, then it won't be a problem. Why? Because it will say that okay, current is not head, current is not head, current is not head, and current is the moment current is head, then I'm actually coming back. So the things will be over, right? So instead of starting from here, instead of saying current equal to head, let me just say current equal to head next, right? Which means I'm starting from here, and in that case, result will be actually starting from 1. So result will be 1, right? So that is how you can modify the code. Then obviously, like let me actually modify the code correctly, and then let me tell you that how you are going to check the null pointer exception also, because you need to take care of the null pointer exception. So let me just shift this little away so that I have some room to write current initialization. So I do need to write head next, right? And then you can say yes, this will work, right? But before that, I mean, this is the correct code, but before that you actually need to check whether head is null or not. Because if head is null, because head is not storing anything, if head is null, then this will actually be a null pointer exception, because null next does not make any sense. So whenever you are doing something of next, then you always check whether it is null or not. So you will say that if head equal null, then return 0, because the length is 0, right? Otherwise the length is default 1, and then you are checking the things, right? Okay, so what if there is only one node? So how will the first of all, how will the circular linked list look like if there is only one node? Let me just check whether it is working only on one node. But before that, tell me how the circular linked list will look like if there is only one node. This is head, which is pointing to this node, which is just a little box, and this is pointing to itself because there is only one node. Then tell me what will be the head next? Head next and head are actually same, because if this is 1000, then this is 1000, because it is pointing to 1000, and it is also pointing to the 1000. Then head next and head are actually same. So basically in this case, if there is only one node, if there is a zero node, see, if there is a zero node, then return 0 is always true. If there is a one node, then head next and head are same actually, right? So this is as good as saying head. Let me not modify the code, it is actually head next only, but the value is only 1000. So current is having the 1000, and because head next is just 1000 and head is also 1000, so 1000 not equal to 1000, it is also false, because actually they are equal. So that is why it will come out of the for loop immediately. If there is only one node, it will come out of the for loop immediately, and result will be 1, so 1 will be returned. If there is only one node, then things are fine. If there are multiple nodes, then also things are fine. So this code will work if you are taking care of the thing that the current should be starting from the next node, right? Current should be starting from here. If there is only one node, then also it will work. There is no problem, right? If you are pointing, if you are asking the current to point to the same thing which the head is pointing, like in this case, so it will be a problem, right? Because it will always be false. So you can modify the singly linked list code. Instead of null, you can have head. There is no problem, because earlier I was just checking for the null. Here I can check for the head, right? So anyway, you do not need to write the code in the exam. You just need to run the code on the given example. So if there is some code is given to you, then just take one example. Okay, take one linked list example and just try running the code. And take the corner cases. Corner cases are like 0 nodes, 1 node, and multiple nodes, right? So suppose this is given to you. Then how you will do? You will take one example. Let me do what you will be doing in the exam, or for the practice purpose, right? So suppose this is given to you, then what you will be doing, you will be checking whether it is printing the linked list correctly, or it is printing the length of linked list correctly or not. So what you will be doing, you will be taking one example. So suppose that this corner case is covered, like if head is null, then it is returning 0. Okay, suppose this is covered, then return 0. Then you will take a simple linked list and then you will check, okay, this is head which is initially 1000 and current is also 1000. So current is also 1000, right? 1000. Then 1000 not equal to 1000. This is false. So it is not returning the length. So that is how you can say that, okay, it is not the correct code. There is some modification needed. So anyway, you can you should be able to analyze the options. That is all you required for the gate purpose, right? So we can modify this code like this, or we can also use do while loop, okay, to print the length, because do while loop does what? Do while loop says that, okay, let me first make a move and then I will be checking. So do while loop are actually popular in these cases. See, let me just draw a circular linked list and let me tell you how it is working on the length. Okay, suppose this is your circular linked list. Okay, again and again I'm not writing that basic check, which is if head equal null then return. Okay, if head equal null then return 0. Okay, so anyway you can write it. So head is pointing here and current is also pointing here, because I am asking current to point here. Then what I'm doing, instead of immediately checking whether current is head or not, I'm saying I'm asking the current to move to the next first, okay, to the next position first. So current will move to the next position first and result will get incremented, and then I'm checking whether current is head or not, right? So do while loops are quite popular in these cases, right? So whenever you have to make a first move, I mean you have to actually increment this current at least once, then you can use the do while loop, or you can also use the for loop. There is no problem, right? Anyway, let me move to the next slide. So I hope that is okay. So above function works almost every time but doesn't cover the case when list is empty. So actually you can insert a check which is if head is not equal to null, equal null, then return 0. This check you can write, right? Okay, let's just see what it is doing. So this is printing the circular linked list. So earlier I was basically finding the length. Now I'm just printing the circular linked list. Again, will this work? No. Why? Because I'm passing the head or front or anything, and then I'm immediately checking. I'm assigning that value and immediately checking whether it is not equal to that or not. It is as good as saying I equal to 0 and I is not equal to 0. I'm immediately checking if I is not equal to 0. So that won't work, right? That kind of things won't work. So that is why this will also not work, right? So I can use do while loop, or I can basically modify that for loop also. So we can print the circular linked list using this do while loop. You can do it or at your own. Okay, just take circular linked list, have 0 nodes, have 1 nodes, have multiple nodes. Try seeing whether it is working on all these 3 cases. I think 0 nodes it will just not print anything. On 1 node and multiple nodes it will anyway work. So actually it will work. Okay, you can try doing it. It is as similar to the counting the length. Okay, now let's see this question. Which of the following prints the last node of the circular or circular non-empty linked list? Okay, so here let's not worry about the linked list where you are only having 0 nodes. So let's say that linked list is non-empty. So in that case I want to check whether which option is correct. Okay, so let me do one thing. Let me erase this, and here only I will be analyzing the options. Okay, so let's analyze this option, which is option A. So option A is having something like this, where okay, linked list is actually not empty, which means at least 1 node you have, right? So suppose this is the linked list. Tell me if this is printing the last node, which means is this printing this? So head is currently pointing here. So you are saying that current to point here. Okay, just analyze. If you are able to analyze, then it is okay, right? You do not need to write the codes. So while current next is not equal to head. So tell me if this kind of while loop is there, then after this while loop, where you will be standing? Current next equal to head, you will be standing here, right? You will be standing here. After this while loop, you will be standing here. So after this while loop, you can say that current next should be head. So you will be standing here, right? So after this while loop, your condition will be this. So your linked list will look like this, where head is pointing to the first node and current is pointing to actually the last node. And then you are printing that value. So I think A will work. This A will work. I hope you got it, right? So this is very simple. Now see, this is not having 0 node, so it may have 1 node. So let me quickly check what if there is only 1 node. So head is pointing here, right? And what if there is only 1 node? So this kind of circular linked list suppose you have. So current will be pointing here, and if there is only 1 node, current next is not equal to head. So current next is actually equal to head, right? If there is only one node, then I will terminate this, I will not even enter in this while loop, and I will come here immediately, right? And I'm printing the value of current. So I think this is fine, right? Because if there is only one node, then this while loop is actually unnecessary, right? And actually I won't be able to even enter in this while loop. Why? Because current next and head are actually same, right? Because current next is, this is 1000 and this is also 1000. Current next, which is 1000, and head is also 1000, because both are pointing to the same node only, right? So in this case also it will work. So A is actually the correct answer. Now let's analyze the other options. So let me analyze this B. Okay, so let's just see whether this V is correct or not. So what this B is doing, let me quickly erase this, and maybe here I can analyze this B option. So let me draw a linked list where you have multiple nodes. Maybe you can have one node also, doesn't matter. Let me first draw multiple nodes. So current is pointing to head next. So they are saying that current, you are starting from here and head is already there, right? Now after this while loop, obviously you will be standing here, right? At the end you will be standing, right? At the end. So there could be multiple nodes, actually there could be multiple nodes, but after this while loop you will be standing at the end. Let me draw multiple nodes if you are not much convinced. So there could be multiple nodes, right? And after this while loop you are actually standing this at this position. Why? Because this while loop will be false only if you are standing at this position where current next and head are actually equal, right? Now you are printing the current value, so I think this should also work, right? For multiple nodes it seems like it is working. What if it is, if there is only one node, right? Current and head, so the head is pointing here and current is pointing to head next. So see, head next and current are actually like head next and head are actually same, because this is head which is 1000 and this is also 1000. So current will be pointing to whatever head next is pointing to, because of this line. So head next is pointing here, so current will also be pointing here, right? And now current next and head, so current is pointing here, current next, which means this 1000, and head, which is 1000, both are actually same. So that's why it will not go into inside the while loop, and it will actually print the current value, which is actually the last node only. So that's why B will also work, right? So A and B both will work. Okay, so what about C option? Let me quickly check it. Let me quickly check the C options and C and D options also, right? So let me erase this, and here I will be checking the C and D option. I hope you are getting the things right. So you just need to analyze the options. That is all you need to do. You do not need to write the code. You do not need to run the code or anything else. Okay, so in C option, what do we have? We have some code like this. So let me make a linked list and let me check whether it is working on multiple nodes or not. See, okay, sorry. So yeah, so head is pointing here and current will also point here because of this line, which is saying let this current point to whatever head is pointing to. Now I'm saying current is not equal to head next, which means after this while loop I will be actually here, right? I will be actually here. Why? Because this will be false only when current and head next are equal. So after this while loop I will be here. So that is okay. That seems like it is working, right? Or there is some problem. See, now I'm printing the current value. So what is the difference between C option and A option? Um, okay, I think by mistake maybe I have done both. Okay, no, this is current is not equal to head next. Okay, current is not equal to head next. So here in the C option I do have current is not equal to head next. So let me see. Yeah, sorry. So after the initialization, current will be pointing to sorry. After the initialization, current will be pointing to this thing which is here, and then I'm saying current is not equal to head next, right? So head next means this thing, right? This address. So if current and head next has to be equal, which means after this while loop, current will be actually pointing here, right? Because in that case only current and if current is pointing here, then sorry, current will be pointing here, right? Current will be pointing here. Why? Because in that case only current and head next will be actually equal. So after this while loop, after this complete while loop, the current will be pointing here. Initially it was pointing to whatever head was pointing to. Now it will point to whatever. So take the opposite of that, which means you just say current equal to head next. which means it will point to whatever head next is pointing to. So head next is pointing here, so current will also point here. Now I'm printing current value. Is this printing always the last value? No, it may print the second value, right? So that is why C is not the correct option. Similarly, you can analyze this D option. D is also not the correct option. Maybe they are based on some data or something. So D is also not the correct option. Okay. So let me move to the next slide. I hope you are getting what I am trying to convey. Now, let's see how to insert a node at the end of circular linked list. Suppose that this is a circular linked list that is given to us and I want to insert a node here. Now, what do you think what I need to do, right? At the end I want to insert. Maybe I need to traverse till the end, right? So maybe I will be stopping my traverse here till this point, and then I will ask this pointer to point here and this pointer to point to what head is pointing to, right? So let's just write a simple code. I think it should work. Let me try writing it. So first I can create a node, maybe something like this, struct node star, maybe you can say end node or anything, right? End node equal to malloc, like you can write size of struct node here. Okay, now let me set this value, maybe end node, whatever value you want, value data, okay, whatever field I'm using, equal to 5, and maybe next equal to null, right? Okay, now let's go to the end of circular linked list, which means let me write a while loop. So currently I have just created this thing. Now let me traverse till the while loop. So what condition I need to put? Just tell me what condition I need to put in the while loop. I need to stop at this point, which means I will say current next and head should not be equal. So I will say current next is not equal to head, right? This will make sure that I am actually standing at my desired position, current next, right? And then after this while loop I will be standing at my desired position, which means I will be standing here. Now what do I need to do? At the step 3, make some pointer adjustment. So what do I need to do? Let me maybe draw a linked list here, or let me copy this diagram, or maybe let me try explaining from here only. Okay, end node is pointing here. So see, what do you want? Current is pointing here, end node is pointing here, and head is pointing here. What do you want? You want like first of all I want you to write the code. I want you to write this as step 3, and after writing this then only watch this lecture ahead. Okay, so do not watch this lecture before writing it. Okay, just pause our video and write the pointer adjustments. So basically what do you want? You want this pointer to point here and this pointer to point here. I think this should be the 2 line of code. So like as a good practice, you should be first be making the adjustment for the end node, for the newly created node. Why? Because this is actually currently pointing to null. So just make this point to whatever you want it to point to, because if you do something wrong, then you are not actually losing anything, because you know it is null, right? But suppose you are asking it to point here maybe first, and then maybe you are losing something, then it should not be a good idea. Okay, in this case actually it won't matter. I will tell you why. But always as a good practice, ask your end node or the newly created node to point to the desired location. So where this newly created node should point to? See, this should point here and this should point to whatever head is pointing to. So you can say end node next should be equal to head, right? Very easy. You can say end node next should be pointing to whatever head is pointing to. This line will make sure what? This line will say that okay, it is pointing to whatever head is pointing to. And then what? Then you will say that okay, this pointer, which is actually current next, should point to whatever end node is pointing to, right? So you can say current next should point to whatever end node is pointing to. That is all. You can do the pointer adjustments, right? That is how you can insert at the last. So okay, this is curr or current, like whatever the symbol name you can write it. Okay, whatever the variable name, maybe curr just. Okay, anyway, I hope that is fine. So you can do it, and last step is pointer adjustment. I'm using the new node or the end node or anything, so you can do it like this, right? New node next equal to head, current next equal to new node. So I think the similar thing we did. New node next equal to head, current next equal to new node. Yes. Okay, so this is the valid code. Okay, now let's see how to insert at the beginning of circular linked list. So beginning means that if you insert this at the beginning, then this should point to whatever this head is pointing to, and head should start pointing to here, right? and this, like, I think there are 2-3 adjustment, and see, this head should be started pointing to here, this should point to this, and this should also point to this, right? So this is tricky, which means you want the last pointer to also be modified. You want this to modify, and this should be pointing to whatever your newly node is pointing to, right? So that is why you anyway have to traverse till the end, even though you are inserting at the beginning, but you have to traverse till the end because you have to modify this pointer. There is no escape, right? There is no escape. So as a step one, you can say that let me create a newly node, let me ask the newly node to point to whatever head is pointing to. There is no problem. But as a step two, you have to traverse till the end, and then you have to ask this pointer to point here, right? Even though you are inserting at the beginning, but you have to traverse till the end because you have to modify the last pointer, and then head should be pointing to here, right? Head should be pointing to the data. That is how you can do it. Anyway, do you recall one thing? Like, if you see these two steps, then do you just recall that this is as similar to as what we have just seen. And what is that we have seen? Inserting at the last. Yes, inserting at the last. See, this is as good as saying inserting at the last, right? And you just need to make one more adjustment. You can just say that whatever the code you had for the inserting at the last, you can say that in that code you will be writing head equal to new node, and that is all, right? So I think here you, if you just say head equal to new node, this is all you need to do to insert at the first, right? You insert at the last actually, okay, you insert at the last and ask your head to point here because it is a circle, right? It is a circle. So these are the nodes. You just insert at the last, and instead of pointing ahead asking to point here, you just point here, you just make it as a first node, right? So anyway, like, it will be clear after a few exercises, after a few questions, but for now just visualize it, okay? That it is actually as good as saying inserting at the last, and then you are asking your head pointer to point here. So if you want, I can actually quickly revise the whole procedure again, or you can do it, okay? I mean, you just need to add one more line, that is all, right? So let me do one thing. Let me quickly revise the whole procedure, and before that I will just ask you to basically replicate the steps that we have already done. Replicate this step 1 and step 2. I will help you with the step 3. Just replicate the step 1 and step 2. So what was the step 1? Take a pause this video and replicate these steps. So first, create a node. Maybe create a node. How? Using maybe end node, first node, or some node. Let me just write this is first node. First node equal to struct node, first node equal to malloc, and all these things, right? If you want, I can write, otherwise this should be fine. Struct node star equal to malloc and all. Okay, I have created a node which is a first node, and then what I need to do, I need to ask this first node to point to maybe whatever head is pointing to. So let me just do this. This first node next should point to whatever head is pointing to. Yes, this step is completed, I think. Okay, and then you traverse till the last. So how to traverse till the last? You actually need to make a pointer current. You will say the current next and head should not be equal, right? So while current next is not equal to head, right? And current equal to current next. And what is the current? Current is a struct node type pointer. Struct node current, which is initialized to head. Okay, and then what do you want? I think this step is completed, and then you can just replicate the step this thing, which means current next should point to whatever this new node is pointing to. So maybe you can say current next should point to whatever this new node is pointing to. New node or first node, whatever you have written. First node, okay? First node. And then I think this first node should point to the head, that line I have written here, or you can shift this line here also. And after that, the third line is remaining, which is basically this one. Okay, I have erased it, which is basically saying that head should be pointing to whatever this new node is pointing to. So you can say head. After this, you can say head should be pointing to whatever the first node is pointing to, which means like this, right? And you are done. So that is all we need to insert at the beginning, right? So it was inserting at the beginning. So we have seen inserting at the end, inserting at the beginning. Similarly, you can have inserting at the middle also. So it will not require much modification, right? So this is how we can basically insert at different positions, right? Okay. In case of circular linked list.